Good morning, everyone. Today, I'm going to go through the coding section of GraphQL. Basically, this is some documentation on how to create your GraphQL server. So I'll go through the documentation and see if I can build a GraphQL server. I haven't done this before, so let's see how long it'll take. So it says there are many different programming languages GraphQL supports, but I'm going to stick to JavaScript and Node Express kind of frameworks. So let's see how far I can get with that. So this, sorry about the airplane noise. So this list contains some of the more popular server-side frameworks, client libraries, and other useful stuff. Okay, so let's see what server libraries are available. So they're saying in JavaScript, we have a graphql.js server library. So what does it say about GraphQL.js? They have some prerequisites. We'll be using graphql.js to build our GraphQL server to begin with. So let me let let me build something using GraphQL. So before getting started, I think they're saying I should have Node v6. So let me see if I have Node v6 already. So I'm going to try to open a terminal and see. So terminal, I'm opening terminal, just give me a minute. So I opened the terminal. So let me see what version of Node I'm running, or if I have Node to begin with. So this is saying I have Node version 4.1.0. That's not what I want. So I need to install the latest version of Node. I wonder if I have even NVM. I don't even have NVM. And NVM is a good way to install Node. So let me go ahead and install NVM first, and then using NVM, I'll install the latest version of Node. So what is the version of NPM? Let me check what the version of NPM I'm using. So let me see. NPM -- version. So that's 4.2.0. So Node.js, if I go to the Node.js, so they're saying the LTS version is 6.10.3. Maybe I'll use that LTS version. To install it, I think I need to install NVM. So let me see, install NVM. This is the Node version manager. So I could use something like this to, using curl, I could use something like this to install. Well, let me see if I have curl to begin with. Okay. Okay, so there is curl, so I could use curl to install it. So I'll go ahead and use this curl command that they gave us to install nvm. So they're saying the script clones nvm repository, blah, 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 and adds source line to your bash file, blah, blah, blah. Okay. So it's saying they add the following to the bash profile. You can customize the install source directory profile and version using nvm source. We will skip all on OS X. If you get nvm command not found after running the install, one of the following might be the reason. I'm using OS X. So your system may not have a .bash profile where command is set up. Simply create one with touch and run the install script again. Okay. So let me see if there is a bash profile. Let me see. Tilde dash bash underscore. Yep, there is not. So I'll go ahead and create one. Okay, I'll create one, and then they're saying if I don't have it, and run the install script again. So I'll run the install script again. Okay, so I ran the install script again, and let me see if I can find the install script. Yep. So it is there. So now I will go ahead and see if I can do nvm version. Okay, nvm command not found. So let me close the terminal and restart another one. And let me see if this will work. Oh, nvm. Okay, so let me make this a little bigger. Did install. It installed 0.33.2. So I don't know what the existing version is, but let me check. So package.yeah, it's the right version. That's the version I have, 0.3.33.2. So I have nvm. So now I can see if I do nvm ls, it should show me I have something. So I think if I say nvm install v, so I want to install the latest LTS. So I'll say I want to install v version 6.10.3. So let's see what happens. It's downloading that version, which is 6.10.3, and then it installed it. So now if I do nvm ls, so it's showing that I have yep, basically it's showing that the current version is 6.10.3. I think I can delete the older version, I think, which is, I don't know what these others are. Okay, 4.3. So let me see if I can uninstall the older version, uninstall v 4.8.3. Let's see if that'll go away. Version not applicable. Okay. Anyway, so at least I have something to get started. So I installed it. So I'll close this one, close this, close this. So I installed. So they're saying that to create a new project. Okay, so let's see. Before getting started, I need to have Node 6 installed. I installed Node 6. So we won't use anything that will require transpilation, which is good. But we'll use ES6 promises, classes, and fat arrow functions. That is good. The latest new features. So to create a new project and install graphql.js in your current directory, I can do this. npm init install graphql save. So this utility up. So let me make sure I'm in the right folder to begin with. So I'll go to the projects folder, and then I'll go ahead and create a, let me see what other folders I have. So I just have a Udacity folder. I'll just create a GraphQL server folder. Let me call get test. I'll call it sample GraphQL server. Or maybe I should rename it to something else. So I think to make sure the name conforms to, okay, so this has, so where am I getting? Okay, getting started with GraphQL.js. So I'll just call it GraphQL.js server. I'll go there, and then I'm going to do the npm init and npm install commands. So npm init. So it's asking me what should be the name. I'll leave the name as GraphQL.js server. Version is 1.1. Description. Testing graph. The sample GraphQL server based on graph using, let's say, I'll say using graphql.js, something like this. Entry point, I'll leave it as index.js, test command. I don't know if you want to test anything, so I'll leave it blank. No git repo and keywords. I'll just say it uses graphql.js, and we'll add others later. Author, I'll leave it as blank for now. License says that's good. Is this okay? I'd say yes. Okay. So now if we see, we have a package.json. So now I can do more. I will go ahead and add this install step to it. Okay, so that's much better. It's a little bigger font. So I'm going to do npm install, and I will do a graphql -- save. So this will install GraphQL. Perfect. So now we are going to create the server itself. So to handle, let's see what are the contents of the folder now. Now we have node modules and package.json. So we have two. I didn't create the index.js, so maybe I am supposed to create it. Yeah. So if I look at package.json, package.json is saying, yeah, it's saying my main file is index.js. I think here they're using server.js. I can always change my file name, but let's see. Let's go through. I'll read this whole thing, and if needed, I'll change it. So to handle GraphQL queries, we need a schema that defines the query type, and we need an API root with a function called a resolver for each API endpoint. For an API that just returns hello world, we can put this code in a file named server.js. Okay. So they're saying we need a schema that defines the query type, and we need an API root with a function called resolver for each API endpoint. For an API that just returns hello world, we can put this code in a file named server.js. So to handle GraphQL queries, we need a schema that defines query type. So they have a schema that defined a query type. I think it has only one field called hello, which is a string. And we need an API root with a function called resolver for each API endpoint. So they have a API root function called resolver for each endpoint. So inside so they have they defined another object. So they have a schema object which which is doing this build schema. Oh, okay. So first thing first, I think we import GraphQL and build schema from the graphql.js JavaScript file. Sorry about that. So to handle the GraphQL queries, I think we have to define a query type and then all this stuff, okay? And a resolver for an API that just returns hello world, we can put this code in a file named server.js. Okay. Okay. So this is a simple server. So if we go through this code once more, so they're saying GraphQL itself, I think instead of server.js, we'll just use index.js. So I'll go ahead and open index.js. It's pretty much empty right now. So index.js. I'll start from the bottom. First thing I need to require GraphQL. For that, I'll use const. I mean, we are using ES6. So I'm going to use ES6 notations. So GraphQL, and looks like I need to import these two objects from GraphQL. So I went ahead and imported those two. So they're saying then I need to create a schema. If you look at GraphQL itself, here I think it's taking two things as input to construct a GraphQL query. It takes the schema itself, which is this part, and then So it's saying that, hey, it is querying for hello itself, and the root is exposing only hello right now. Okay. So let's go ahead and type this and see how it behaves. So let me create a schema. So we are creating a schema using GraphQLs. So we are creating a schema using GraphQL schema language. I think we can call this anything, but let's say we called it query. We are creating a type called query with one field, with that field's data type is a string, and then so this is how you create a schema. If we use require ql.js, I think. And then we need to define a root that provides a resolver function for each API endpoint. Okay, so let's say we want to do root. I'm saying root is a function. This is nothing but the resolver. 1, 2. Return, it just returns hello world. And then you're passing where this is, I think, GraphQL schema, and then let's see what we are doing here. Let me type it up and try to understand what we are really doing here. Somehow they say that a good practice is to always put your function arguments in this parenthesis when you're handling something in promises. So I'll go ahead and do that. So GraphQL schema, hello world, hello root, then response, console.log response. So I'm guessing this is doing nothing but this is saying that, hey, for this GraphQL, my schema, so, and then if someone queries with hello, then what we are saying is go look at the resolvers in root, and if there is a resolver that matches hello, then return hello world, is what this is saying. So let's assume that we understood, assume that I understood what I'm talking about, and then let me see. So if I run node with index.js, then it should print out the data. Okay, so node with index.js, yep, it printed it out. Now that we have a basic example working, so let me see if I can add more to it. So let's say I'll clear this. I'll I will update this index.html. Let me see if I run GraphQL with something else. I don't want to run it with hello. I'll say I want to run it with hello one. Let me see what will happen. Yep, it threw an error because hello one is not a, there is nothing called hello one. There is no and there is nothing called hello1. So what is the difference? Hello is a resolver. So we are saying, hey, I want something called hello. And the root object is saying, hey, there is nothing called hello. Okay. So if I add hello1 here, then I'm thinking everything will still work. A hello1 there and a resolver for hello1, then it'll work. So basically here we are saying, hey, you can query on something called hello, and this one is saying we defined a resolver, and the resolver is saying, hey, this is how you get hello1. And when we execute the query, this is where we are executing the query, and it's returning that response. If that's the case, let's go and tinker with index.html and see. So we are saying the user can query for a field called hello. Let me say I want to say the user can also query for something called world, and let's also give it a string. And then I need to add a resolver for world. So let me see if I can add a resolver for world. I'll say a resolver for world should return. I'll say it should return world with exclamation also. And then I'll close that, and then I'll go ahead and update. Hello should only return hello. So const, that's the schema, and this is the root. And in root we are saying hello world, and world this is okay. So we have two things the user can query. The user can query for a field called hello and a field called world, and for when the user calls hello, it will come here and it will return hello string. And with when the user, if the user queries only world, then it will come here and return world. So let's say I will only query for hello, or let me go ahead and query for hello and world also at the same time. I'll say, hey, I want these two. Let me see if I get anything back. I'm going to run node index.js, and now you can see I queried for hello, it returned the hello string. If I queried for world, it returned the world exclamation. Okay, that is good. So I just executed a GraphQL query. So basically, this is how we execute a GraphQL query, is what they're saying. So you build. So to execute a GraphQL query, first thing we need to get the GraphQL library. I think to do that, we need to install in our project. We need to install it as a dependency. I think we did that. So if you look at package.json, if you look at package.json, we see a dependency called GraphQL. We installed that GraphQL dependency. That gives us a lot of things. That gives us a way to build a schema and a way to query also using GraphQL. So we then went ahead and defined a schema. And inside the schema, we said, hey, we have a type of query with a field called hello. And so because we defined something like hello, we need a resolver. And so we defined our resolver here inside a variable called root. And then for the query itself, when we said, hey, I want to query for hello, we ended up passing in the schema itself, hey, the definition of how our schema looks. And then we said, hey, that's the definition. And then I want the field called hello. And we are saying you can resolve hello using whatever is defined inside root. And then we got a response and we posted the response back. So they're saying for practical application, you'll probably want to run GraphQL queries from an API server rather than executing GraphQL with command line tool. Yeah, here we executed using command line. We typed in on the command line, we typed node space index.js. They're saying instead of, if you want to do querying using an API server, we need something more than GraphQL, is what they're saying. To use GraphQL for an API server over HTTP, check out running an express GraphQL server. Okay, that's the next part of it. Running an express GraphQL server. Okay. Let me take a few minutes break and then I'll come back. So the first part, we just used GraphQL.js. I think it was mainly, if we, it's not an API server. If I want to run something from command line, maybe that's good enough. But if we need something more complicated, looks like we need to use something like GraphQL, Express GraphQL server. Continue reading. Oops. Where did it take us? I don't know how I ended up here. Oh, okay. This talked about, okay, continue reading. Okay. What happens if I click on this? Okay, this talks about how to install an Express GraphQL server. Okay. So this will be good. So I'm going to go ahead and change to that project. I'll go ahead and go one level below and create a brand new project, a brand new folder called, I'll call it Express GraphQL server. So I have that Express GraphQL server here. If I just do an ls, you'll see it. I have Express GraphQL server. So let me go to that Express GraphQL server folder, and I'm there. So what they're saying now is the simplest way to run a GraphQL API server. So this is an API server, is to use Express, a popular web application framework for Node.js. You'll need to install 2 additional dependencies. Okay. So because we created a brand new project, trying to see if I should continue using the old project or if this should be a brand new one. Because they are not doing an npm init or anything like that. So it might not be a bad idea to just go back and use the other one. Okay. So these are the files that we have in the old one. So we'll continue using this. So they're saying the simplest way to run GraphQL API server is to use Express. So to use Express, we have to install Express. So that's what they're doing here. A popular application web framework from Node.js. You will need to install 2 additional dependencies. One of them is Express GraphQL. Okay. Let's go ahead and install that. I'll say install. I'll install Express first. Okay, it's installing Express. So if I see package.json, then I should see Express now. So it installed Express 4.15.3. Okay, so now I'll go ahead and install Express GraphQL, and I'll save it to package.json. Now if I see package.json, I should see Express GraphQL also. It installed 0.6.6 of the Express GraphQL package. So earlier, if you see, we had their Express and GraphQL. Now we have one additional item here. Cool. So now we look at the rest of the documentation. We'll be modifying the hello world example so that it's an API server instead of running it as a script that we were earlier querying for hello world together. So now if we have an API server, we have more flexibility. So we can use the Express module to run a web server. And instead of executing a query directly with GraphQL functions, earlier we used the GraphQL function. We can use the express-QL library to mount a GraphQL API server on the /GraphQL HTTP endpoint. Basically, express-GraphQL will let us will let us create a GraphQL API server, and we can use the endpoint /GraphQL to query for data, is what they're saying. So now if I go back, so let me make this a little bigger so we can see both. So let me go back to index.js. In index.js, now that we need express, so we'll say we want to require express. And then we need the GraphQL HTTP server also. So we'll say GraphQL HTTP server. So this will serve the HTTP traffic. Express GraphQL. And then we won't be querying from command line, or we won't be creating a query within this because it's an API server. We'll just use the build schema feature of GraphQL. So we continue to do we using build schema. We create something like this. We create a schema with type query. We'll leave because we added hello world also. We added hello and world. We'll keep it as is. It's a little different from what's given here, but it's pretty much the same. So we create a schema using something like this, and then we have resolvers. We created 2 resolvers, one for hello and one for world. Because this is an express server, we'll go ahead and create an express server object. And then we say, so whenever the user comes to a route like express, whenever the user uses a route like GraphQL, then we want to define a handler for it. We'll say, hey, my handler for something like this will be we'll have a schema called a schema, and it'll have a root value of root. So this is the resolver, and then graphql is true. It's a good practice to end everything with a comma. If any call this function, and this function will use a schema that we defined here, and then it will have a root value of root, which is nothing but it has a bunch of resolvers, and graphql true. I don't know what that means. I'm guessing that will allow us to use the explorer, but we'll get to it. I'm sure they'll explain it further down the code. Okay. Now we need to listen on a port. So I think they picked 4000. I'm okay with 4000 port. I don't have anything listening on port 4000. So that's it. So after that, I think if everything works, I think this console.log statement will be printed. So I'll also go ahead and type it up. Okay. Wonder if there is an easy way to do. Okay. Here, so we can see the entire thing. So as you can see, I missed adding a code there. Okay, so we don't need this because we are not going to do anything command line. So we'll remove this. So I'll add an extra line at the end. So anyway, so we are listening on, so we are creating a GraphQL-Express server, and the schema it'll use is this, and root is this. The root has the resolvers, and GraphQL is true. So I think, I'm guessing this is the Explorer part of it. So let's see, now that we have this, so if I save and exit, now you can run this using node server. So let's see, node index.js. So it's asking something. I said allow. So now we are running. So now we are saying if I go to localhost port 4000 GraphQL, I should be able to do some stuff. So let's see. I'll move this over here. I'll remove the unnecessary stuff here. They're saying I should be able to do something like localhost and port 4000 slash GraphQL. Eating some breakfast while talking. Sorry about that. So I think this is what it is. I think it's GraphQL true will give us a nice explorer. So I can type something like, hey, I want fields hello. If I say I want fields hello and run it, it's giving me the hello. So if I want to get world also, I can do something like this and do hello world. So it's giving me those two fields. It is simply awesome. So that's what they're talking about here. If you see, they're saying since we configured GraphQL HTTP with GraphQL true, you can use the GraphQL tool to manually issue GraphQL queries. If you navigate in a web browser, this is what we did. You should see an interface that lets you enter queries. It should look like the following. Okay, that's exactly how it looks like. So this screenshot shows the GraphQL query hello being issued and giving a result of data hello world. Okay. GraphQL is a great tool for debugging and inspecting a server. So we recommend running it whenever your application is in development mode. So we should run it only in development mode or what? At this point, you've learned how to run a GraphQL server and how to use a GraphQL interface to issue queries. The next step is to learn how to issue GraphQL queries from client code. Okay. I think here, if we look at this, I think we jumped. Okay, these are the 3 ways they're saying we can use. I wonder what the difference between this express GraphQL and this GraphQL server, what the difference is between these two. Hmm. I have to read the documentation about GraphQL server to see which one to use and when and why. Okay. Let's go into this GraphQL clients. I'll look into the Apollo Express package a little later, but let me see what they're talking about GraphQL clients. Actually, this GraphIQL itself is a client. So, but let's see. Since a GraphQL API has more underlying structure than a REST API, there are more powerful clients like Relay, which can automatically handle batching, caching, and other features. But you don't need a complex client to call a GraphQL server. With Express GraphQL, you can just send an HTTP POST request to the endpoint you mounted your GraphQL server on, passing GraphQL server, GraphQL query as a query field in the JSON payload. Okay. So if you use clients like Relay, they're saying that it'll automatically handle batching, caching, and other features. So for example, let's say we mounted a GraphQL server on this endpoint, as in the example code for running an Express GraphQL server. Okay, and we want to send a GraphQL query, hello. We can do this from the command line with the curl. If you paste this into a terminal, okay, we should see output blah, blah, blah. So Let's run the curl command in a new tab. So let's see what happens. Yeah, we got the data back. It returned the following data. It's also simple to send GraphQL from the browser. Okay. I was saying I can send it from the browser console. So, okay. Basically, I create a HTTPL request, XML HTTP request, and then it returns back something. Okay. Let's see. It said it failed. Failed to load resource. The server responded with a status of 404. Oh, I wonder why this is not a full path. Mixed content. Okay. It thinks I'm on a Google domain, so it's not allowing me. So I can actually go here and open the developer tool here because I'm here on localhost already. This should allow me to, this should give me back stuff. Yeah. So this gave me back hello for the hello field. Cool. So you should see the data returned logged in the console. Okay, we did. In this example, the query was just a hard-coded string. As your application becomes more complex and you add GraphQL endpoints that take arguments as described in passing arguments, you will want to construct GraphQL queries using variables in client code. Okay. You can do this by including a keyword prefixed with a $sign in the query and passing an extra variables field on the payload. For example, let's say you're running the example server from passing arguments that has a schema of type roll dice, so num dice and num slides, and it returns an array of integers. Okay, you could access this from JavaScript code with, so I defined, so they defined two variables, one called 3 and the other one called 6, and then the query, oh, okay, so they're saying I could use the $keyword and then no, I think, okay, so I pass something like, to the query, I pass something like variables. Is that what they're saying? Okay, and that will return Then go ahead and update the code. So in this case, let's say hello world takes hello world takes let's say my in my scheme I have hello world and it takes num dice, which is of type integer, and then num slides, which is of type integer, and then returns a string. If I have something like this, so the implementation, I'm guessing this implementation will fail. Let's see. Let me add another tab here. Whoa. Let me add a third tab. If I add another tab here, okay. So in this other tab, I'll just go ahead and run the server. So I ran this server. So now if I go back to the UI, and then if I run the UI, will I get anything back? Yep. Oh, I didn't provide, it's saying that I didn't provide num dice, which is required. So that's the reason it's complaining. So if I say num dice, I think if I say something like 5, will it work? Let's see. Syntax error, hello 5. Expected name found int 5. Expected name. Okay. So, okay. So we can only pass something by variable, I think. So how do we do that? So let's see. Okay, dice. So so I have to say num dice and then give it a variable. Okay. Num dice has value 5. Num dice on field hello of type query. Unknown argument. Okay, so do we need to refresh this or something? Okay. Unknown operation named null. Okay. So let me go and see what is this passing arguments. So passing arguments, okay, type query roll dice, query num dice, and then when you implement it, roll dice, args, okay. It takes some args, so I need to set args. Is that what it is? So if I go back here, I should say that this one is expecting args, even if I don't use it. Then restart it. And then I will go ahead and refresh my graphql and see if anything shows up there. Still doesn't like it. Unknown operation name null. Okay. I don't know why this is required. I thought we didn't make it mandatory, but still. But back to the code. Just said num slides. I didn't say it's required or not. But it looks like it. Without that, it's not working. So if I take this out, it was working. I don't know why it didn't work earlier. Anyway, I'm going to refresh this and see. I don't know what the other error is. So even if I don't do this, will it return me an error? If I just say hello, will it throw an error? Yeah, it's saying that num dice of time is required. So if I enter num dice and do nothing, it will still fail. So I need to assign it a property. Let's say I give it some string, it will still fail. Or it's throwing an error here itself. Okay. If I say 5, then it will work fine. Okay. Understood. So here they're saying that I can have arguments and pass those arguments. I wonder what the difference between there and here is. Here also we are sending a query. We are sending our query is hello to that endpoint. And here we are saying, hey, our query is we want to get roll dice. I wonder what this is. What's the difference between this and this? Here we are just doing query, and here you're saying query, we are passing variables also. So it's roll dice. I don't know where this is defined. So we're just giving a name to the query. Is that what it is? And then that is ending up calling this. So using this syntax for variables is a good idea because it automatically prevents bugs due to escaping, and it makes it easier to monitor your server. In general, it will take a bit more time to set up a GraphQL client like Relay, but it's worth it to get more features as your application grows. You might want to start out just using HTTP request as the underlying transport layer and switching to a more complex client as your application gets more complex. At this point, you can write a client and server in GraphQL. For an API that receives a single string, for an API that receives a single string. To do more, you will want to learn how to use other basic types. Okay, so this is, we just made a client. In this case, a client that takes two values. That's all we did here. Continue reading basic types. In most situations, all you need to specify the types for your API is GraphQL schema language taken as an argument to the build schema function. The GraphQL schema language supports the scalar types string, int, float, boolean, id. Most situations, all you need to specify the types for your API is GraphQL schema language taken as an argument to the build schema function. GraphQL schema language supports scalar types of string, int, float, boolean, and id. So you can use these directly in the schema you pass to build schema. By default, every type is nullable. It's legitimate to return null as any of the scalar types. Use an exclamation point to indicate A type cannot be nullable. So string is a non-nullable string. String exclamation is a non-nullable string. To use a list type, surround the type in square brackets. So int is a list of integers. Each of these types maps straightforwardly to JavaScript. So you can just return plain old JavaScript objects in APIs that return these types. Here's an example that shows how to use some of these basic types. Okay. var express equals require express. GraphQL HTTP. Okay. So basically, we are importing the express package. We are requiring the express package, express GraphQL build schema. Okay. So they're showing us construct a schema using GraphQL schema language. This is the schema. So the root provides the revolver function for each API endpoint. A resolver function, sorry, not revolver. Yeah, we know that the root provides that. And then they're showing quote of the day, take it easy, salvation lies within, okay. Random, okay, it's just giving a math random value. Roll 3 dice. Okay. This is like a new notation. Wonder, I don't know why they didn't use the parenthesis notation here instead of this. So it's one less character to type, I guess, but I didn't know that this is a valid notation. So what they're doing here is quote of the day, math random, if it is less than 0.5. Okay. So let me update my code with this. Okay, so let me run the node server again. And let me run the graphql to see what I can query. So if I query for I think my query has quote of the day. Let me just get quote of the day. Quote of the day. Doesn't take any arguments. And then I'll say I want quote of the day and random. Okay, give me some random number. Let me do roll 3 dice. Okay, give me something else. 141. Okay. Okay. These examples show you how to call APIs that return different types. To send different types to an API, you will need to learn about passing arguments to a graph API. Okay, passing arguments. Just like a REST API, it's common to pass arguments to an endpoint in GraphQL API. By defining the arguments in the schema language, type checking happens automatically. Each argument must be named and have a type. For example, in the basic types documentation, we had an endpoint called roll 3 dice. Instead of hard coding 3, we might want a more general function that rolls num dice, each of which have num sides. We can add arguments to GraphQL schema language like this. Okay. Okay, the exclamation point indicates num dice can't be null, which means we can skip a bit of validation logic to make our server code simpler. We can let num sides be null and assume that by default a die has 6 sides. Okay. So far, our resolver function took no arguments. When a resolver takes arguments, they are passed as one args object. Okay. As the first argument to the function. So roll dice could be implemented as, okay. Initialize the output to an empty array. Then for var I equals 0, biceps. If there are 6 dice, then we'll have to do it 6 times. So I'm guessing he's checking. Yeah. On the output. Okay. Back. Yep. That's what it's doing. Okay. It's convenient to use ES6 destructuring assignment for these parameters. Since you know what format they will be, so we can also write roll dice as. Okay. This will reduce some. Okay, so it's if you're familiar with destructuring, this is a bit nicer because the line of code where roll dice is defined tells you about what the arguments are. Okay. The entire code for a server that holds this roll dice API is yeah. Roll 3 dice, I think it's the roll dice. Okay, roll dice, and then it takes that, output is empty. Okay, we push it, okay. I'll have to restart node, restarted node. And looks like when you call this API, you have to pass each argument by the name. Okay. So far, the server above could issue this GraphQL query to roll 3 sides. Okay. So let me look at that. All right, num dice. Dice is, let's say, 5. Num sides 6. Okay. 1, 2, 3, 4, 5. Okay, there are 5 dice, and num sides is 6. Okay. So they're saying if you run this code with Node server.js and browse to, you can try this out. That's exactly what we did. When you're passing arguments in code, it's likely better to avoid constructing the whole query string yourself. Instead, you can use dollar syntax to define variables in your query and pass the variables as a separate map. For example, some JavaScript code that calls our server above is, okay, this is the one that we looked at earlier. He's stringifying this entire thing before sending it out. So let's see how this looks. I'm going to go ahead and open the console. I'll type something here. Okay. I'll say const x equals blah, blah, blah. Okay, x is not defined. Uncaught expected. Oops. Okay, x. Okay. Trying to see if Stringify did anything. Basically, Stringify added these escape characters for new line, and at the end also, it's returning a string with all this data in it. So if we use variables, they're saying that we don't have to worry about escaping characters. So anyway, so let me run this here and see what comes back. Saying it returned some data. So if I go into the data, it expanded the data. So I rolled the dice 3 times and I said there are 6 sides to it. So it gave me a random side. Anyways, okay. This part I still don't understand properly. Okay, using $dice and $sites as variables in GraphQL means we don't have to worry about escaping on the client side. Understood. With basic types, the argument passing, you can implement anything you can implement in a REST API. But GraphQL supports even more powerful queries. You can replace multiple API calls with a single API call if you learn how to define your own object types. Okay. In many cases, you don't want to return a number or a string from an API. You want to return an object that has its own complex behavior. GraphQL is a perfect fit for this. In GraphQL schema language, the way you define a new object type is the same way we have been defining the query type in our examples. Each object can have fields that return a particular type and methods that take arguments. For example, in the passing arguments documentation, we had a method to roll some random dice. If we wanted to have more and more methods based on random die over time, we could implement this with a random die object type instead. Instead of a root level resolver for the random die type, we can instead use an ES6 class where the resolvers are instance methods. This code shows how random die schema above can be implemented. Class random die. Okay. Basically, the resolver is implemented by the resolver in this case get die based on the number of sides. It's returning something. Let me take a few minutes break. I'll be back in a minute.
Find a time where you will not be disturbed. Sit or lie down. Whatever thoughts come and go in your mind at this point, simply observe. Find a time where you will not be disturbed. Sit or lie down. Whatever thoughts come and go in your mind at this point, simply observe them as if from a distance. Now, notice your breathing, and especially the still point between breaths. Breathe in through the nose to the count of 4 and out to the count of 6. Don't strain to do these breaths. Just do them as best you can, whilst focusing on that still place between inhaling and exhaling. If thoughts intrude, see them as coloured balloons, as separate from you, and let them go. Let them float away. You are present now. You are not controlled by your thoughts. You can acknowledge that they are simply that, thoughts. They proceed from you, but they do not own you. You control them. Recognize that fact and let them go, to be driven away by the wind. Be conscious of the beat of blood within you. Of the rhythm of your breathing. The brush of clothing against your skin. Feel the surface on which you sit and how your body presses into it. Be aware of any scents that you can smell, colours you can see. Notice the detail in the sounds you are hearing. Feel the temperature of the space you are in. Spend some moments simply being aware of all that is within you and around you right now, in this very moment. This is what it is to be mindful. When you are ready, begin to go about your daily life once again, content in the reassurance that you can return to this mindfulness guide whenever you choose.
Ah. So coming back to this object type section, in many cases, they're saying you don't want to return a number or a string from an API. You want to return an object that has its own complex behavior. GraphQL is a perfect fit for this. In GraphQL schema language, the way you define a new object type is the same way we've been defining query type in our example. Each object can have fields. So basically we define an object like this, give it a name. Instead of query, we give it its own name. That's what they did with random die. Apparently something like this is not a field, it's actually a method. So here they distinguish between methods and fields. They say each object can have fields that return a particular type and methods that take arguments. So looks like this can be called a method because it takes arguments. I was earlier referring to roll dice as field, but looks like it's supposed to be a method because it's taking arguments. For example, in the passing arguments documentation, we had a method to roll some random dice. If we wanted to have more and more methods based on a random die over time, we could implement this with a random die object type. Okay. So looks like if we want to add, so right now there is only one method called roll dice. So if you want to add more methods, then we can create a new object. We can create a new object type, and that can have all these methods. So here they defined a method called getDie. In getDie, you're passing in optional num sides, and it is returning you a random die object. Instead of a root resolver for random die type, we can instead use ES6 class, where the resolvers are instance methods. So looks like a resolver for this, a resolver for random die. A resolver for random die is pretty simple. It'll be an ES6 class where the instance methods are the resolvers. So here, if you see, there is something called random die. It takes a constructor. It has a constructor that takes num sides as the argument, and then it has these methods. I think these methods will turn into resolvers. And then if you see, getDie is doing nothing but it's taking num sides, and then it's returning a new random die. Let's see. So for fields that don't use any arguments, you can use either properties on the object or instance methods. So for the example code above, both nemsides and role ones can actually be used to implement GraphQL fields. So that code also implements the schema of. So for fields that don't use any arguments, you can use either properties on the object or instance methods. Okay. So it looks like this field doesn't take any arguments. So this will be a field. And if a field takes an argument, then it'll be a method. I think it's, let's see, you can use either properties on the object or instance methods. So for instance, for the example code above, both nemsides and role ones can actually be used to implement GraphQL fields. So that code also implements the schema of. Okay, I didn't understand that properly. Basically, they define nemdi, you're passing nemsides to random die, and random die has all these things. And roll once, I think the resolver for roll once will just roll it once and return the result. So nem rolls takes an argument, so they're saying, hey, that will be anyway. So let's look at the implementation details. So here, if you see build schema, they define random type with 3 fields. One of them is nemsides, the second one is role ones, the third one is a method, or the field takes arguments. So this will be, yeah, we'll see. So this has 2 fields and 1 method, I'm guessing, if I got the notation correct. So this class implements the random die GraphQL type. So here, if you see, how will they get access to nemsides? So there is no concept of private variables in a JavaScript class. So it looks like they can just access nemsides as is without a getter or setter. So the role ones resolver is just saying that, hey, roll it once and then give me the results. Okay. So in the root, we have get die, which is doing nothing but returning a new random die, and then that's what we are passing. Okay. Okay. So basically, he's saying, yeah, get die will give you access to the resolvers within the random die object, and then the random die object, you could do all these things. So let me see how this works. Let me copy this code as is, and then I'll copy this and try to run it in GraphQL and see how it looks. So see how many lines are there. Let's say 40 dB. I'm going to copy the code as is. This one has random die as the resolver, and it defining in the schema. We have two things. One is called random die and a query. And the query is doing nothing but it's doing the get die, and which is a random die. Okay, let's see what happens. So now if I do a get die, and I'll say num sides. If I say num sides is, let's say 8 sides, I want 8 sides. And then I want something within it. I'll say I just want inside get die, I just want the, what is that? Num sides. If I do this, what do I get back? Okay, I'm getting back num sides as 8, which is good. And then I'll say I want roll ones. What do I get if I do roll ones? I get 7. And then if I say roll, and then number of rolls. Okay, so I'll say num rolls. I say 10. Let me see what I get back. If I roll it 10 times, what do I get back? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay. So when you issue a GraphQL query against an API that returns object types, you can call multiple methods. Okay, let's see if I can call this method multiple times also. Oh, it will not work because I can't have duplicate, I think. So if I do roll once, I think it will not work, I think. Let me see. Yeah, it didn't work. Basically, it gave me roll once only once. So if I do num sides, I'm sure that same thing will happen. So I only have, I don't know why it's not throwing an error if I give it a duplicate field. But anyway, so for example, if you want to call both roll once to roll a dice once and roll to roll die 3 times, you could do it with this query. So if you run this code with node server browse, blah, blah, blah. So the way of defining object types often provides advantages over traditional REST API. Instead of doing one API request to get basic information about an object and then multiple subsequent API requests to find out more information about that object, you can get all of that information in one API request. That saves bandwidth, makes your app run faster, and simplifies your client-side logic. So far, every API we've looked at is designed for returning data. In order to modify stored data or handle complex input, it helps to learn about mutations and input types. So far, every API we've looked at is designed for returning data. So in order to modify data or handle complex input, it helps to learn about mutation and input types. Okay. So mutation and input types. If you have an API endpoint that alters data, like inserting data into a data store, or altering data already in a database, you should make this endpoint a mutation rather than a query. This is as simple as making the API endpoint part of top-level mutation type instead of top-level query type. Okay. Let's say we have a message of the day. Let's say we have a message of the day server where anyone can update the message of the day and anyone can read the current one. The GraphQL schema for this is simply set message string. Okay. It's often convenient to have a mutation. It's often convenient. So basically they have with type mutation, you can have set message. With query, you always do a get. It's often convenient to have a mutation that maps to a database create or update operation, like set message. Return the same thing that the server stored. That way, if you modify the data on the server, the client can learn about those modifications. Both mutations and queries can be handled by root resolvers. So the root that implements this schema can simply be, okay, for resolving it, they're saying, how do you resolve something like that? You don't need anything more than this to implement mutations. But in many cases, you'll find a number of different mutations that all accept the same input parameters. A common example is that creating an object in a database and updating an object in a database often take the same parameters. To make your schema simpler, you can use input types for this. By using the input type keyword instead of the type keyword. For example, instead of a single message of the day, let's say we have many messages indexed in a database by the ID field. And each message has both a content string and an author string. We want a mutation API, both for creating a new message and for updating an old message. We could use the schema. For example, instead of a single message of the day, let's say we have many messages indexed in a database by the ID field. And each message has both a content string and an author string. We want a mutation API both for creating a new message and for updating an old message. We could use the schema. Okay. I think this input is again a keyword. And okay. So basically, for creating a new message, we require a brand new message. We require a input with input of type message input, which has two fields, content and author in this case. In using that, we create a message, and it returns message as the output, and it returns message as the output, and this has the ID of the string, the content, and the author. Basically, whatever they inputted, whatever is in the input will be returned back along with a new ID. So basically, the message itself has a unique ID. And for updating a message, the user has to send the ID of the message they want to update and the new message input. The new message input obviously again has both content and author, and then it returns the object of type message. Cool. And the query again will just get an existing message, and it requires you to pass it an ID. Pretty straightforward. Here the mutations return. So here they're saying, so let me minimize the rest of the windows so it's easier to focus. So here they're saying here the mutations return a message type so that the client can get more information about the newly modified message. Request as the request that mutates it. Input types can't have fields that are other objects. Only basic scalar types, list types, and other input types. So naming input types with input on the end is a useful convention, because you will often want both an input type and an output type that are slightly different for a single conceptual object. Here's some runnable code that implements this schema, keeping the data in memory. So here they're building a schema with an input called message type and a object called a object type called message, and query and mutations, two mutations. So they implemented okay, so the implementation of message, they implemented the message object. I don't know why it's implemented as a class, but maybe, yeah. Okay. So yeah, maps username to contact a fake database, and then so they implemented the message object type as a simple class, ES6 class. that takes ID, content, and author. So ID is required, but content and author are not required. Is that what it means? Okay. So it looks like the user can create a message, send an input with content and author being blank, because we are not requiring them to be non-null. But the ID has to be non-null. So in the root, I think get message is is a resolver within the query. It's a resolver for get message in the query type object, query object type, I guess. It takes ID, and if the ID is not found, then they're saying no message exists. If it is found, then they return. So we create a new message and return. Yeah, we're returning a new message. So create message, create a random ID for our database. Oh, this one is using the crypto package. Okay, so looks like crypto has to be installed, I guess. So it's a 10 character. You're asking for 10 random bytes. I don't know if this will be globally unique, but let's for our testing purposes, let's say it's unique. So whenever the user wants to create an input, we create an ID first, and then we in the fake database objects ID property, we are assigning the input. We are assigning input to the fake database's ID property. So we return a new message with this ID and input. And to update, whenever we are updating, we want to check and see if this exists. If this doesn't exist, then we throw an error exception because we can't handle it. And if it exists, then we change the input and send it back. Okay. Var app express. Okay. App.use, GraphQL, GraphQL HTTP, schema, root value. Okay. So this is talking about instantiating, creating the server itself. So they're saying to call a mutation, you must use the keyword mutation before your GraphQL query. Okay. I wonder how this works. So here, not here, I think. If I look at GraphQL, will this also return me something? Yep. I think I can also give it a name, I think. Yep. But if I put something like this, it'll fail. Okay. Understood. So to call a mutation, you must use the keyword mutation before your GraphQL query. To pass an input type, provide the data written as it's a JSON object. Okay. Create message takes an input object. And we're asking it to output the ID. Okay. So let me copy this into index.js and see how this works. So in my GraphQL, I can first query and do a get message. And let's say I want to send it an ID of 1. Let me see if it'll give me anything. Get message. Cannot query get message. Okay. Refresh. Let me look at get message once more. Get message takes an ID of something. Okay. Let's take an ID of string or. Oh, it takes an ID of ID type. Huh? Doesn't like that. Okay, so it gave an error saying that, hey, no message exists. No message exists with this ID 1, 2, 3, 4, 5, 6, 7. Okay, so I don't know why. Oh, get message ID by itself. So if I do something like this, will it still work? Of type message must have a selection of subfields. Okay, so basically this returns an object. So because it returns an object, looks like I need to specify the subfields. So it returns a message. So typically that message has an ID, content, and author, I think. Yeah. It'll return nothing. Understood. So that's the query part of it. So if I do a mutation, I will do a mutation. In the mutation, I'm going to say I want to create a message. This takes the first parameter is an input. The input takes author. Author is best, let's say A, and content is C. Complaining Create message input. It doesn't like that. No, it doesn't like that. Okay. Did you mean to use double quotes? Unexpected single quote character. Oh, okay. The JSON object, so create message. So I want ID. Must only be defined. Oh, okay. This phenomenon must only be defined operation. I don't know what this means. Okay, it takes create message. Takes that as input. Content author. Okay. Okay, let's see. So the mutation, this mutation was able to insert something. You can use variables to simplify mutation client logic, just like you can with queries. For example, some JavaScript code that calls server to execute this mutation. Okay. One particular type of mutation is operations that change users. If I take out the mutation, if I query, why does it not like this? Get message. Okay. Syntax error, GraphQL, expected : found parenthesis. Okay. So it is a string. It needs double quotes, not single quotes. And I do a query. So one particular type of mutation is operations that change users, like signing up a new user. While you can implement this using GraphQL mutations, you can reuse many existing libraries if you learn about GraphQL with authentication and express middleware. Okay. Authentication and express middleware. It's simple to use any express middleware in conjunction with express GraphQL. In particular, this is a great pattern for handling authentication. To use middleware with a GraphQL resolver, just use the middleware like you would with a normal Express app. The request object is then available as the second argument in any resolver. For example, let's say we wanted our server to log the IP address of every request. And we also want to write an API that returns the IP address of the caller. We can do the former with middleware and the later by accessing the request object in a resolver. Here's the server code that implements this. In a REST API, authentication is often handled with a header that contains an auth token, which proves what user is making this request. Express middleware processes these headers and puts authentication data on the express request object. Some middleware modules that handle authentication like this are Passport, express-JWT, and express session. Each of these modules works with express GraphQL. Express session. If you aren't familiar with any of these authentication mechanisms, we recommend using express-JWT because it's simple without sacrificing any future flexibility. If you've read through the docs linearly to get to this point, congratulations. You now know everything you need to build a practical GraphQL API server. I haven't used express-JWT before, so looks like this is one way to use it. We'll look at that later. So looks like I need to look into this implementing authentication and express middleware. I looked at Passport a while back. So if you aren't familiar with any of these authentication mechanisms, we recommend using blah, 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 constructing types. Constructing types for many apps, you can define a fixed schema when the application starts and define it using GraphQL schema language. In some cases, it's useful to construct a schema programmatically. You can do this using GraphQL schema constructor. So we can use GraphQL schema constructor to create schema instead of doing it using the schema language. Instead of defining query and mutation types solely using schema language, you create them as separate object types. For example, let's say we are building a simple API that lets you fetch user data for a few hard-coded users based on an ID. Using build schema, we could write a server with, okay, maps ID to user object. We can implement the same API without using GraphQL schema language. How is that? We're saying define the user type. Okay. Define the query type. So this is, you can use this instead of the GraphQL schema. Don't know what is the best practice. I think this one is done programmatically. So will it throw an error when we start creating these objects? I don't know if because GraphQL schema is a string, I don't know if you do something wrong in the string itself, if it'll throw an exception when you start your GraphQL server. But looks like this might catch problems at a more granular level. But anyway, so once we go through it, we might know. Define the user type. Okay, we define the user type, give it a name, and then the fields that go in it. Same thing with query and the fields that go in it. It's still considered a field, even if you have arguments, but looks like you can use both notations. I think in some cases, they just strictly use the field notation of field. Yeah, so they call them fields, and in some cases, they're called fields methods, especially if you pass arguments to it. So, but when you define a GraphQL object type, looks like you define it within fields and say that, hey, these are the arguments. There is an argument called ID, which is of type GraphQL string. Oh, you define a resolver there itself. Okay, they defined a resolver there also. So it takes an ID and it's returning fake database ID. You have to see what are the pros and cons of using this GraphQL object type to define your GraphQL schema versus the other one, versus defining GraphQL schema in the schema language. I don't know what the advantages and disadvantages are. So when we use this method of creating the API, the root level resolvers are implemented on the query and mutation types rather than on a root object. Oh, so here it is. When we use this method for creating the API, the root level resolvers are implemented on query and mutation types rather than on a root object. This is particularly useful if you want to create a GraphQL schema automatically from something else like a database schema. You might have a common format for something like creating, updating database records. This is also useful for implementing features like union types, which don't map cleanly to ES6 classes and schema language. Okay. So they have more information about this express-GraphqL. So if I look at it earlier, I think the earlier one at the root level, looks like when we create something like this, it is created at either the query or mutation level. So we passed in a value called root value root, and in this case, we are passing the schema object to the schema property when we instantiate the GraphQL server. Okay. I think unless I start playing with it on a real application, I wouldn't know when to use what. But I'll go to the next section, express-GraphqL. This express-GraphqL, the express-GraphqL module provides a simple way to create an Express server that runs a GraphQL API. So, okay, this is the signature for the GraphQL HTTP server creation. So I can pass in either a schema or graphql, is it true or false, root value, basically the root resolver, and context, pretty, I don't know, pretty, I think it'll prettify the output. Format error, validation rules, okay. This constructs an express application based on a GraphQL schema. See express-QL tutorial for sample usage. They have a tutorial also. Oh, we just read this whole thing, I think. Yeah, I'm already done with that. See the GitHub README for extensive documentation of the details of the method. Okay. Okay. I'll read that later. So this, the next one is the GraphQL part of it. We looked at we looked at this to create a simple uh, command line node based application earlier. It talks about how to set it up. Nothing out of the ordinary here. I think the next one is about, it's talking about GraphQL error. So if I want to know, if I want to interpret the error, I would use this, I think. Okay. GraphQL execution. GraphQL language. So the GraphQL language module is responsible for parsing and operating on the GraphQL language. Okay, you can import either from the GraphQL language module or from the root GraphQL module. I'm going to skip this because I don't know when I'll really use this. I think once I start using it, I might need to come back and revisit this. GraphQL types. GraphQL type module. Okay, this is another module, is responsible for defining GraphQL types and schema. And you can import either from GraphQL type module or from the root GraphQL module. Okay. I'll skip this also. The utilities module contains some common useful computations to use with GraphQL language and type objects. You can import either from GraphQL utilities module or from the root GraphQL module. Okay, this helps with introspection, I guess. And to skip this also. GraphQL validation. This validation module fulfills validation phase of fulfilling a GraphQL result. You can import either from GraphQL validation module or from the root GraphQL module, for example. Okay, that's it. Cool. I think that is like my first shot at trying to learn this GraphQL. I think that I have a bunch of best practices. So I need to relook at it. So they have a bunch of best practices for authorization, everything. So I think I need to relook at that when I start coding. I'll start with being a client, and then I will look at other stuff. So for now, I will go ahead and end this. We'll take a look at it. I'll end this Google Hangout for now, and then I will start coding a small app and see how I can use GraphQL. Maybe I should try to create a small app to query data from GitHub and see. Just use a simple client to access data in GitHub. That's one way to start. Thank you, whoever joined, but I'll go ahead and stop this broadcast, and maybe in the next one, I'll try to use the GitHub's GraphQL API to access GitHub data.